Wilcoxon mesh pair sign rank test. Learning outcomes. At the end of the topic, students should be able to making inferences to related sample by using Wilcoxon mesh pair sign rank test. For the definitions, need for case of two related sample when the measurement scale allow to determine not only whether the member of a pair of observation differ, but also the magnitude of any difference. Assumption: the data for analysis consists of n values of the differences, which is di equals to yi minus xi. Each pairs of measurement xi, yi is taken on the same subject or non-subject that have paired with respect to one or more variables. The sample of xi, yi pairs is random. The differences represent observation on a continuous random variable. The distribution of the population of differences is symmetric about their median MD. The differences are independent. The differences are measured on at least an interval scale. This is the hypothesis. There are three cases. For case A, two-sided, which is equal. H null MD is equal to 0. H1 MD is not equal to 0. For case B, one-sided, which is increased. H null MD less or equal to 0. H1 MD greater than 0. For case C, one-sided, which is decreased. H null MD greater or equal to 0. H1 MD less than 0. This is the test statistic. Obtain each of the sign differences by di equals to yi minus xi. Rank the absolute values of these differences from smallest to largest. Absolute di equals to absolute yi minus xi. Assign to each of the resulting ranks the sign of the difference whose absolute value yielded that rank. Then lastly, compute depend on H1. T positive equals to the sum of the rank with positive signs, while T negative is the sum of the rank with negative signs. For the ties, there are two types. When yi equals to xi for a given pair, then we having di equals to yi minus xi equals to 0 and reduce n accordingly. Then for the second one is when two or more value of absolute di are equal. Decision rule. Hypothesis for the case A, H null MD is equal to 0, H1 MD not equal to 0. The test statistic, we will either take T positive or T negative, for which is smaller. For case B, H null MD less or equal to 0, H1 MD greater than 0. Test statistic is we will take T negative. And lastly, for the case C, H null MD greater or equal to 0, H1 MD less than 0. The test statistic, we will take T positive. Example for small sample. Dick Key et al. Studied hemodynamic changes in patients with acute pulmonary thromboembolism. Table 4.6 shows the mean pulmonary artery pressure of 9 of these patients before and 24 hours after urokinestography. We wish to know whether this data provides sufficient evidence to indicate that urokinestography lowers pulmonary artery pressure. Let alpha equals to 0.05. The data for x and y is given in the table below. First step is we need to make the hypothesis by referring to the question needs. The hypothesis is H null MD greater or equal to 0, H1 MD less than 0. The claim is on H1. For the second step is to find the test statistic. The calculation of the test statistic is shown in table below. First of all, we need to find the difference between variable of x and y, which is di equals to yi minus xi. For the first row, our di is 21 minus 33 equals to negative 12. Then we need to repeat the step until we reach the last row, which the difference is 9 minus 18 equals to negative 9. We can see that on second row, the difference between variable of x and y is equal to 0. For this case, we will eliminate it from the next step. After that, we continue with finding the rank of absolute di. The rank will start from the smallest to the largest. In this case, 3 is the smallest and become the first rank, followed by 5 the second rank, and 7 the third rank, and so on. Then for the last column, we need to find the sign rank of absolute di. For every rank of absolute di, we will follow the sign from the difference, which is di. For example, the sign rank of 7 is negative 7 because we take the sign from the difference di. Then we will repeat the step until we get the sign rank of the last row. Lastly, we will total up all the value of t negative and t positive. Next step is to find the p-value. The n now is become 8. And we will select t positive equals to 0 as our test statistic, depends on the hypothesis that is in case C. By referring table A.3, when n is equal to 8, t is equal to 0, our p-value is 0.0039. Therefore, 0.0039 is less than 0.05, which is alpha. The reason is we will reject H null. There is enough evidence to support the claims that urokinase therapy lowers pulmonary artery pressure. Exercise for small sample. Exercise 4.4. This is the given data. The answer is T positive equals to 35, T negative equals to 10, the p-value equals to 2 multiplied by 0.0820 equals to 0.164. The decision is do not reject H null. Exercise 4.5. This is the given data. The answer is T positive equals to 1.5, T negative equals to 34.5. The p-value is in between 0.0078 and 0.0117. The decision is reject H null. This is the formula for large sample approximation. We will use this formula when n is larger than 30. Therefore, z is equal to t minus, in bracket, n multiplied by 1 divided by 4 over set n multiplied by n plus 1 multiplied by 2n plus 1 over 24. Exercise for last sample. Exercise 4.16. This is the given data. The answer is T positive equals to 331.5, T negative equals to 196.5. The p-value is equal to 0.98118. The decision is do not reject H null.